All right, it's about the time to start our class today, and I'm happy that some of one of you uh, is coming uh, this week. So actually, I think we still have 3 students outside the country or in quarantine. And but anyway, using Teams, then those of you are still cannot be in the classroom, then you still can have our class. And I hope that you can hear it very clearly, and also uh, you can also join our class uh, on time. All right. Then I think I'm going to start it, continue chapter 1. You all have textbook. Have you ordered the book? And oh, it doesn't matter anyway. Uh, you need to have the books or either ebooks. Okay, so as long as you can read the textbook. Although I know that many of you doesn't really have a good habit to read the books, especially for textbook. Okay, but anyway, I think this subjects has more, you know, uh, professional, knowledge. So you need to do some further readings. I mean, deep readings. Okay, in order to understand this concept, is especially for those who uh, don't take any statistics when you are in undergraduate students. Okay, uh, but those who may take it, but most of the topic or the concept uh, is already forgot it. Okay, you need to take this time to review it and to study hard. Okay, and I already mentioned that from now on, excuse me. All right, and let me show my screen. Then all of you can see the materials, which I like to cover. Most of the time, I will use the PPT, and sometimes I'm using the whiteboard, or sometimes we have to practice using computers. Okay, so those who are online, if I'm writing something on the whiteboard, uh, I'm really sorry that you cannot see anything from the Teams. Okay, then when I show you how to work on the computer's program, then I think I will show on the screen first, so everybody can follow me. Uh, those who in the team on the Teams or in the classroom. Okay, I hope everything is working well. All right, let me show the, okay, before we are going to discuss the material today, I like to show you how to download the data from the iLearnings. Okay, you you all need to download those data from iLearnings. Okay, so if we do once, then I think you can download all the data from the data set to your computers. Then you don't have to do it every time. Okay, we download the whole set. Okay, We download the whole set of the data. Okay, so I'm going to show you how to do it. First of all, go to the iLearning, class iLearning. Okay, let me do it also at the same time. All right. So I'm going to the CYCU. All right, then I'm going to the iLearning. So I'll I'll hit the iLearning function first. Then now key in your accounts and the password. All right. After that, you can have your iLearning just like I. It's not exactly what I have, but you have your own class. Hey, what happened? What's wrong with my screen? The screen is not on. Okay, then you will have the screen something like this one. Okay, go to the class which is research methods. Okay, then go to the enter course function. All right, or now you do have two material on this online. One is called website data set, and this is the data set. I wanted everybody download it to your laptop. Okay, once will be okay. So download this one, right? And you'll see this one. This is our Teams recording, class Teams recording. Okay, so from now on, if I use the Teams, then after the class, our assistant will help me to upload all these recordings to the iLearning system. So if you want to review the material we cover in the class, come to here. You can come to here also, or you may just go on to the Teams and you can watch the recordings. Okay, all right. So just download it since I already do it. So please download it. Okay, then let me out of here. Then I will have this data set. Okay, now let me turn it on, the data set. Okay, this is the data set covered all the data from this textbook. Okay, so from chapter 1. Well, is this one? Excuse me. Do I do the? Oh, yes. Okay. All right. Then, okay. Then, for example, chapter 1, then we have several format of the data set. Okay. In this class, I'm going to use eViews. Okay. Just turn on the eViews. Okay. Now, in chapter 1, we do have two data set. Okay. One is called HTWT1. The other one is RATE1. Okay, after you download it from to your computers, so you can have this data set anytime you want it. All right, and so I'm going to use this one today, and this is another one which is our assignments, for our assignments. So I'll talk talk about that later on. All right. And before doing that, there's a data form is called Excel. Okay. So I like to also show you how to use the Excel, using the Excel data file, move it into the eViews. Okay, because most of the time in the future, if you need to do some work or you do some other assignments with the data, which is in the Excel form, because Excel is more popular than eViews, right? And all the data we now use it is using Excel form. So if you have that form, Excel forms of data set, then you can transfer the Excel file into the eViews, which is very easy. Okay, so as long as I know how to, so let me also download this. Okay, let me download it here. All right, then I can show you how to do it. Okay, so I'll do this one first. All right. Okay, so let me have all this data set when I up to this point, which I need to explain the examples, then that's started to explain how to work with the using eViews. All right, so I like to continue our topic, which we have it from last week. Okay, all right, and okay, let me show this one. Let me show this PowerPoint. Is this one? Okay, we already talked about what is econometrics last time. Does anybody tell me what is econometrics? Especially we were working on this regression analysis. We focus on the regression analysis in this class, although we have a lot of research methods. Okay, so I will emphasize on the quantitative methods. Okay, only the quantitative methods. So I'm not going to teach anything about the qualitative methods. It's not covered in this class. Okay, and we'll focus on the quantitative methods, especially the regression analysis. All right, so all the regression analysis, all this, we have another, the subjects called econometrics. What is that? What do you mean by econometrics? Anybody tell me the definition of econometrics in a very simple way? Anybody? So I like to say that we can examine the data and to quantify the actions of the firms or consumers or government. Okay, this is the easy way to say it. We can examine the data and to quantify the actions of customer or firms or government. Therefore, we need to use a lot of data. Okay, this is what we say econometrics. We have three uses of econometrics. One is describing the reality. The second one is perform the hypothesis testing about the theory and the real data. Okay, the third one is do forecasting. And especially in this class, in this semester, okay, we are going to cover the two uses. All right, and I think I mentioned it before that this textbook can be used for 1 year. Okay, we'll cover from chapter 1 to chapter 7 to this for this semester. Okay, the rest of 7 chapters will be covered next semester for another elective course, which just called econometrics. Because now for the first 7 chapters are more foundation analysis. Okay, and if we really get to the econometrics, which is this one is really helpful for your thesis. Okay, all right. So for the first 7 chapters, usually we are focused on 2 uses. One is the describing the reality. The other one is teach you how to perform hypothesis testing. All right, and for the second session, which I think I haven't really finished, is the topic about what is regression analysis. Okay, and actually, when we working with the regression analysis, I like use these examples. On my left-hand side is called dependent variable. On my right-hand side is the equality. Okay, the left-hand side is called dependent variable, and there's only one variable. Okay, and for my left-hand side of the equality, this equation is called independent variables. And this is a set of independent variables. In other words, it can be just only one variables, or it can be k variables. Okay, as long as the theory, we have the theory behind it. All right, and the regression analysis is after we have this relationship, something like 1.1 equation, then we collect the data. Okay, after we collect the data, then we can do using some statistical methods. Then we will come up with some numbers, something like this one. So instead of showing the relationship, the relationship means the relationship between this is called independent variable and this is called dependent variable. The positive relationship or negative relationship, something like this one. And after we have the data and also those numbers shown here, and we also can understand more of how the relationship between independent variables and dependent variables. Okay, and this is what we call regression analysis. Anything I need to, okay, and we're saying that when we're talking about the regression analysis, we really is to test whether there is any statistically significant and its quantitative relationship exists between dependent variable and a set of independent variable. So remember, when I put on this red ink, means it's important. It is statistically significant, and it is the quantitative relationship. Okay, so when we say statistically significant, it really doesn't mean the causality. Okay, whatever you want, any causality, we need to have more theoretical, behind support. Okay, so actually, regression analysis cannot confirm the causality. It doesn't confirm the causality. It can only test the strength and direction. When we say the strength means those numbers, then I will tell you how to tell how strength it is when we do the hypothesis testing, and directions, either positive sign or negative signs of the quantitative relationship involved in a dependent variable and independent variables. Okay? And we will start it from what we call single equation linear models. For single equation linear models, it can be only one independent variable, or it can have more than one variable. Let me see. Okay, it can be just like one x variables, and it also can be, let me see, anything else? Something like this one. Okay, this is just have one variables and one x variables. And it can be like we have three variables, or either this is the general form of the x variables more than one. So we have k variables. Okay, and all these numbers for the equation is from textbook. All right, and I like to go back to the let's start it from the beginning. Okay, let me explain it also. We do have those what we call beta. Okay, this is what I say beta. And remember, this is the variable of y. This is variable of x. Usually we're using the general form of y to denote the dependent variable, and x to denote the x variables, independent variables. But all these notations using beta, which is Greek letters, okay? And this is called the coefficient. Okay, the coefficient of the regression. This is called regression equation. Okay, since we do the regression analysis, so this equation is called, this equation is regression equation. Okay, so what's the beta stand for? I think based on the math, okay, looking at the equation, whenever we have the equations, math is always involved. Okay, so the beta, what's the definition of those beta based on the math relationship? Okay, it is the coefficient that determine the coordinates of the straight line. This is a straight line, right? Okay, at any points. So if we want to explain it, okay, these two definitions are very important to all of you. Okay, what do we mean by beta zero? Usually we call it constant, or we call it intercept. These two terms is interchangeably used. Okay, either one is okay, constant or intercept. And it indicates that the value of y when x equal to 0, in math, it is. When this is 0, then this is the y values. Okay? And beta 1 is the slope coefficient, and which indicates the amount of y will change when x increases by 1 unit. Means that when x increases or decreases change by 1 unit, what's the amount of y will change Okay? Remember, explanation for this equation is more important than working on the computers. Okay? Maybe now you feel it's not uncomfortable using the eViews, but later on, if you're familiar with how to use the eViews, then working with the computer is a piece of cake. But the explanation of the result from the computer output is much more important than just working with computers. Although we all need to working with the computers in order to get the output, but the explanation or the interpretation of this output is even more important. And this is what you should learn from this class, not just only working with the computers. Okay, explanation, okay, is more important. So you have to understand what's all this meanings. All right? And look at this equation. This is just the general format. And actually for statistical equation, regression analysis, the equation is not really math. The difference between math equation and statistical equation is like this one. What's the difference between 1.4 and 1.3? Look at, carefully. What's the difference between these two? 1.3 and 1.4. This is 1.3, right? This is 1.4. What's the difference? Did you all see this one? This is also denoted in Greek form, Greek letters form. And this is what we call epsilon. Okay, so let's explain it. We say besides the variation in the dependent variable y, that is caused by independent variable of x. Okay, we say that x is going to explain the relationship of y, right? So there still is going to be some variations in y that simply cannot be explained by the model. When we say by the model, means by the x variable. Okay? There still is going to be some variations in y that simply cannot be explained by model. So this variation is called stochastic error term. Stochastic means randomly. Okay, randomly. And we denote it by the epsilon in the equation 1.4. So we know that, in math equations, usually, in math equations, you are able to write down the one-to-one relationship. So for example, if I'm showing the relationship between x, y, for math equation, okay, for example, if this is the relationship between x and y, means when x increase, y decrease. So this relationship is negative relationship between x and y. Okay, in math equation, we do have the points, which falls on the line. This is called math equation, right? Okay, but in statistical equation, okay, I'll show you the statistical equation is something like this one. It's also x and y. But if it is a negative relationship, I do have those line. if it is like this way, is it able to connect all the line into all the points into one line? No. No. Okay. So this means what? Why we do have this one? You see what I'm saying here? Okay. And this parts without this one is what we wanted to find out. If we do the regression analysis, I wanted to find out the relationship of X and Y, which is something like this. I will have a one line. Although those dots is not fall on this line, but they're pretty close to it. Okay, they're pretty close. If I can have this line, then it can explain the relationship of X and Y. But however, we still have some this variations which cannot be explained by the model. This is called model. Regression analysis means this is the model. So this is why I'm saying that there still is going to be some variations in Y that simply cannot be explained by the model. So this terms is called error terms. Okay, and we denote it by E. Right? And what kind of stochastic terms? You know, why do we have those stochastic terms? Okay, then we say that there are several sources of variation. Okay, the first one is, you know, maybe there's many minor influences on Y are omitted from the equation because data are unavailable. You know, we're trying to say that the variation of the Y dependent variable can be explained by all the X variables, but somehow the variation of the Y, there maybe have some influence, but the data, we're not able to collect it. Okay, so this is what I say, those influences are omitted from the equation. Okay, if those omitted variables are very important, then it will cause problems. So we'll talk about that, you know, in the future. Now we are just talking about those equations, those equations which the X variables can be collected as many as possible. But still, in that situation, we do still have some variations. So this omitted variable is just one source of it. There's another three. So the second one is called measurement error. Measurement error. What do we mean by a measurement error? Means there's some mistakes when you collect the data or when you measure it. Okay, this is either by humans mistakes or just unexpected. You know, so there's some measurement errors in the dependent variables. So we later on we also have to cover those measurement error either from dependent variables or from independent variables, and what happens if we do have this kind of situations or mistakes. Okay, so it can be covered. You know, all this is from next semester, not this semester. Okay, or the third sources is the underlying theoretical equation might have a different functional form. When we say different functional form, what do we mean by different functional form? We will talk about this one this semester, okay, in chapter 7. Okay, we'll cover this one. So I will explain this one up to the end of the semester, okay? This functional form is, the definition is related to the math. Okay, I'll explain it later on. Okay, or number 4, this is called unpredictable or purely random variation. So eventually, we have 4 sources of this variations of y, which cannot be explained by the models. So in regression analysis, when we write down the regression analysis, we write down the regression equation. Usually, we put the error terms on it. Okay? All right? We're not just write down the relationship of x and y. So 1.4. Okay, this one, we always put it in statistical model. Okay, this is the difference between statistical model and the mathematical equation. Okay, so here we like to emphasize that a stochastic error term is a term that's added to a regression equation to introduce all of the variations in y that cannot be explained by the included x's. So it is, in fact, a symbol of econometricians' ignorance or inability to model all the movements of the dependent variables. Okay? All right? And what else I want to say? Okay. Let's see. For the equation 1.4, okay, actually we have 2 components. Okay, the first one is beta 0 plus beta 1. We call this components is a deterministic components. Deterministic means already decided, right? Deterministic components is not change. Okay? Components of the regression equation because it indicates the value of y that is determined by a given value of x, which is assumed to be non-stochastic. Okay, so we say we collect the data. We collect what kind of data? We collect y and we collect the x. Okay, and given the value of x, if we know the x variables, according to the equations, although we need to know the beta 0 and beta 1, okay, then we can have the y variables. So as long as you have the beta 0, you have beta 1, you have x variables, value of x variables, and this terms is already decided, is fixed. Okay, so we call it deterministic. All right, and this deterministic components can be thought of as expected value of y given x, or the mean value of y associated with a particular value of x. Okay, in that case, this is the expected of value y given x. Okay, the notation, something like this one. Okay, and this part's equal to this part. So I can rewrite the 1.4 into 1.6, which is y equal to this part is expected value of y given x plus error terms. All right. Any questions about that? And here is what I want to mention, that uh, uh, if I have the x variables, okay, more than one x variables, like 1.8 or 1.11, equation 1.8 and 1.11, and usually we call it multiple linear regression model. And this is just simple linear relation model. If I have just x1, it's simple linear regression model. Okay. By the way, I want to show that in our textbook, and actually they're not using multiple linear regression analysis. I mean the words of multiple. They are using multivariate, and this is misleading. Okay, usually multiple regression is refers to the equation with more than one x variables. We call it multiple regression. Okay, and most of the time multivariate is talking about we do have y variables as well x variables are more than one. I think more uh, usually we differentiate multivariate as the one with y and x variables more than one. But multiple regression analysis, multiple is talking about just only more than one x variables. Y variables is only one only. Okay, understand what I'm saying that? So be careful if you read the books. Okay, some of the books will, really interchangeably use these two words, multiple or multivariate. Okay, and some of the books is really say that multivariate just only emphasize on the y variables more than one and the x variables more than one. But in this class or up to the next semesters, all the regression analysis is talking about just only one y variables, but a set of x variables. It can be just one or more than one. But be careful, y variables is only one. Okay, this is what we call multiple regression analysis. Okay, but in our books, they're using multivariate. Okay, but you have to remember that, some of the authors really interchangeably use these two words. Okay, all right, and I think that it is. This is for the second session, 1.2. All right, so all the example we started from only one x variables, but soon I'm going to extend it into several x variable because I think the realities is more related to reality. Okay, the y variations cannot just explain by one variable only. Okay, usually is many. Okay, then we will, like use the more important x variables. Usually we collect the more important variables first. So it may be 1, 2, 3, 5, something. Okay, which is most of the time. And I believe that your thesis, okay, is not going to use simple linear regression, but just only one x variables. Okay, it should be many x variables. All right. All right, this is about the section 1.2. Any questions about it? You understand what I'm trying to explain it? Any questions? No? Okay. I think this is a good point to to have a stop. Okay. And I'm going to talk about 1.3 later on. Okay. Let's have a break. And let me uh, stop the recording and we'll